Okay, to end this question, what we've been asked to do is we've been asked to find the displacement of the particle over the first 8 seconds of motion. So we've got our graph, and basically we know a graph of velocity is time, and then it's velocity or displacement over time. So to find this out, what we need to do is, if we're finding the area here, in effect we're multiplying time by velocity, velocity or time by displacement over time. So we're multiplying this with displacement. So basically we need to find the area underneath here. So to do that, we go into the first 8 seconds. So what we need to do is anti-differentiate between 8 and 0 for 1 plus 3 t plus 1 with respect to t. Now, to do that, what we do from here is that we would need to break this up. So we'll have between 8 and 0 for 1 dt plus, and we take our 3 out, t plus 1, which is to the power of a half, dt. So this ends up being, we'll take this thing here, and I'll put it over here. So we can differentiate that, and we'll get t between 8 and 0, and that will give us 8. Okay, so that's what we've got there. So now we're going to worry about the rest of it here. So we're going to anti-differentiate this. So remember, we have to use our rule of ax plus b to a power will become ax plus b n plus 1 over the coefficient of x n plus 1. So here we'll end up with 3 t plus 1, that goes up 3 over 2, and we're going to divide that by the coefficient of t, which is 1, so 3 over 2. Oops, trying to have 3 there, change it to 1 over 2. Okay, so from there, and then of course it's between 8 and 0. So then we'll substitute some stuff in. So, well, firstly we'll simplify this. So we have 3 times 2 over 3 t plus 1, t plus 1, 3 over 2, between 8 and 0. So from here we will end up with, the 3's will cancel, so you've got 2 t plus 1, 3 over 2, between 8 and 0. So I'm going to continue this just here, running out of space as well. So now we know that if we've got 3 over 2, if power 3 over 2, that becomes, we're taking the square root and we're cubing it. So we'll have 2 times 8. I'll take the square root of 8, sorry, of 9, because t plus 1, 8 plus 1, so let's just fix that up. 2 times 9, so that's the square root of 9, which we're cubing, minus 2 times the, running out of space again, 2 times the square root of 1 cubed. Okay, so from there we'll end up with 2 square root of 9, which is 3 cubed, 27, minus 2 times 1, which ends up being 54 minus 2, so we've got 52. Now we've got our 52 plus our 8, so we end up with 52 plus 8, so it ends up with 60. So this thing covers 60 units. No, I can't remember what the speed is, but that's when it's not units squared. We're looking at square units, or we're not actually calculating an area. We are using anti-differentiation to find the area under the graph here, which then results in a displacement, which is a linear measure. So to determine displacement, we set up our equation, set in our limits, put in our equation, anti-differentiate, then substitute our limits, simplify and solve.